All right, welcome back, guys. So hopefully we are with it so far, and we're looking at stoichiometry with titration. So this is all the mathematics that we can do based on the balanced equations that we have. Let's take a look at, I have a 50 milliliters of 0.05 molar HCl that I want to titrate with a 0.07 molar NaOH. How much NaOH solution will I need to add to reach the equivalence point of this titration? So where my moles of acid are equal to my moles of base. So we have 50 milliliters of acid. We go ahead and convert that to liters. From liters, we multiply the molarity, and that gets us moles of HCl. Once we're in moles of HCl, by multiplying by that molarity, so 0.05 molar HCl, we're in moles of HCl, then we can look at the molar ratio between HCl and NaOH from the balanced equation. It's 1-to-1 in our balanced equation. So that gets rid of the moles of HCl and leaves us with moles of NaOH. If we want molarity, then we would need to divide by the volume, but we actually want to know what's the volume that we need to do with this. So we need the molarity of this solution that we have. So we go from moles of NaOH, divide by the molarity of the NaOH. That cancels the moles of NaOH. That gives us an answer in liters of NaOH, but we don't want an answer in liters. We want it in milliliters. So we do the conversion from liters to milliliters, and that gives me 35.7 milliliters of NaOH that is required to do that. So that's one of the things that we can look at. Another thing that we can look at is I've made a solution of acetic acid by dissolving 3.94 grams of acetic acid in 25 milliliters of water. I need to add enough 0.045 molar ammonia to react with the acetic acid present. So how much is required? We need a guesstimate. So we balance our equation, acetic acid, CH3COOH, plus NH3, the ammonia, gives me NH4CH3COO, and that is ammonium acetate. That's the salt that's made there. So we take our 3.594 grams of CH3COOH and convert that to moles by dividing by the molecular weight. When I do that, that cancels the grams of acetic acid and gives me moles of acetic acid. But I don't want moles of acetic acid. I need to multiply by the molar ratio of NH3 to the acetic acid to get rid of the acetic acid and get to moles of NH3. But I don't really want moles of NH3 either. I want to know how much ammonia is required. So I need to know a volume. So I divide by the volume of the NH3, the 0.045. That gives me an answer for NH3 in liters. I don't want it in liters, so I do the conversion to milliliters. And that gives me 1329.96 milliliters of NH3 required to do that particular titration. Okay. So notice I've been canceling units to make sure that I've got everything set up the way that it's supposed to be. Now, let's go ahead and talk about some more titration calculations that we can do. So we get over here to this example titration calculations. And I go in my slide deck that I can write on. Come on. And you'll see that I've crossed it out. Let's read it. Calculate the molarity of an acid solution if 34.57 milliliters of that solution are needed to neutralize 25.19 milliliters of 0.1025 molar sodium hydroxide. So I start with that 25.19 milliliters. Okay. And I need to get to moles, so I can multiply by the molarity, which is the 0.0125. But that's in moles per liter. So I need to convert from liters to milliliters to cancel both the milliliters and the liters at that point. Okay, so awesome. So that leaves me with an answer in moles of NaOH. I don't want moles of NaOH. So I know that 1 mole of NaOH reacts with 1 mole of acetic acid. So that gives me moles of acetic acid. I want moles per liter, so I need to divide by the volume and then convert that to liters. So that gives me that calculation that I've done up here, and not the one that I had written here, which is an inappropriate calculation. I don't actually even know what I was calculating. But that gives me 0.0091 molar. Okay, so I have written all of that out in the slide that I will be sending if you want it, because that's the way it should look, not the way that I whatever I wrote previously. I apologize for that. If we want to talk about what volume of 0.25 molar HCl is required to neutralize a 10 milliliter sample of 0.750 molar NaOH, there's 1 HCl reacts with 1 NaOH to give me NaCl plus H2O. 10 milliliters of NaOH, convert that to liters. And actually, so I take my milliliters, I convert that to liters. I multiply by the molarity, that cancels the liters and gives me moles of NaOH. Once I have moles of NaOH, I know there's 1 mole of NaOH for 1 mole of HCl. So that puts me into moles of HCl. If I want a molarity, or I want a volume of that solution, then I divide by the molarity of that solution. So it's a 0.250 mole per liter. That would give me a volume in liters. I don't want it in liters, so I cancel that and convert it to milliliters. And that gives me 30 milliliters of HCl that is required for that, which to me makes sense because one of them is 0.750 and the other one is 0.250. So one is 3 times the other. Okay. Now, a lot of times I have people ask me, do I need to include that molar ratio that exists there? And the answer to that I'm going to tell you is yes, because for me, it makes more sense to always include the molar ratio, even if it is 1 to 1 or 2 to 2 or whatever it is, than it does to have to think about whether or not I need the molar ratio. I'd rather put it there and not need it than not put it there and need it. So let's talk about this reaction down here. In the titration, a 25 milliliter sample of 0.129 molar sodium hydroxide solution was neutralized by 32.72 milliliters of sulfuric acid. What is the molarity of the sulfuric acid? So I take sulfuric acid, H2SO4, I react that with an NaOH to give me NaCl. That's not NaCl, that's NaSO4. And it's not just NaSO4, it's an Na2SO4. So I have 2 NAs on my product side. I need to multiply NaOH by 2 to get 2 over there. So then I have 2 H's, 1 SO4, 2 NAs, 2 OHs. That means I make 2 H2O as my product. So notice the stoichiometry here is not 1 to 1, it's 1 to 2. So we need to make sure that we're dealing with that when we do these conversions. So 25 milliliter sample of a 0.129 molar sodium hydroxide. So I start with my 25 mils. I convert that mils of NaOH to liters of NaOH. I then multiply by the molarity, the moles per liter of the NaOH. And that gives me moles of NaOH. Cancel the liters. There's 1 mole of it, there are 2 moles of NaOH down on the bottom. So that will cancel to 1 mole of H2O. Or H2SO4. So now I'm in moles of H2SO4. I need to divide by the volume, which is 32.72 milliliters of H2SO4, and then convert that milliliters to liters. And when I do that happy math, that gives me the 0.049 molar H2SO4. Now, again, I showed you that, not because that is really accurate math, because it's not. H2SO4 does not behave exactly that way. But to emphasize to you that molar ratio may not be 1 to 1. Okay, so remember to watch for that. All right, that's what you need to deal with there. Okay, so there's my example for that one. So watch for that molar ratio. Questions, comments, problems on any of the calculations that we've done. That covers most of the calculations that you would see. So we can calculate a molarity, we can calculate the volume, we can, that's typically what we do in looking at these things, is we want to either estimate how much of another solution we need to do this titration, or we want to calculate what is the concentration of the solution that I didn't. So that's all of our stoichiometry. So I'm going to take a pause with the stoichiometry before we get into our next topic. I'll see you shortly. Thanks, guys.